Alright guys, this is part 2 on GI. I just left off on the duodenum and how bicarbonate buffers the acidity of the stomach so that the enzymes that break down the proteins, the fats, and the carbohydrates and sugars that aren't necessarily in their simplest form yet can get broken down. Alright, so we need bicarbonate secreted by the duodenum, but primarily by the pancreas, to buffer the acidity of that chyme that just came in from the stomach. Okay, I want to go over one thing real quick. When a patient is vomiting and they vomit a lot, they get rid of a lot of acid. Okay, when we form hydrochloric acid in our stomach, a lot of bicarbonate is also made simultaneously. So on one side of the cell, of the parietal cell, you have the excretion of bicarbonate into the circulatory system, and that gets absorbed and accumulated in the pancreas, and you have the excretion of hydrochloric acid into the stomach, into the lumen side of the stomach, which gets used up. So an individual that has been throwing up a lot will have a low amount of acid and a higher amount of bicarbonate. What happens is that this bicarbonate sits around in the pancreas and doesn't get used. So you are at higher risk of becoming alkalotic. Okay, individual that's been throwing up a lot is at high risk of becoming alkalotic. So back into the duodenum. So we've had the chyme, which has been exposed into the duodenum, and we've already spoken about the duodenum being stimulated by the physical presence of that food, of that chyme being there. Okay, the vagus nerve is still playing a good role here. Okay, the vagus nerve is always playing a role, but the majority of the role is now through the enteric nervous system, which is direct stimulation, direct physical stimulation by the presence of food. You are going to have a lot of mixing in the duodenum. Okay, we said that the esophagus had peristalsis. The stomach has a type of peristalsis mixed with some mixing, and the duodenum and the jejunum and most of the ileum also have mostly a mixing peristalsis. All right, once you get down into the distal ileum and the cecum and the large intestines, ascending, transverse, and descending colon, that is all peristaltic. All right, there's segments that contract to be able to expose things out of your body. But the small intestines like to spend a lot of time with your food. Okay, they want to spend a lot of time to the food because they want to be exposed to all the minerals and all the nutrients and give the enzymes and the acids, which will no longer be that acidic, to break down the particles, all right, so that you could actually get all the nutrients that you can from the food. Because if your small intestines were to just have peristalsis non-stop all the way through, you wouldn't have time for this mixing, and you wouldn't have time for the foods to get broken down, and for every little corner and every little angle of all the particles of food to be exposed. And that brings me to speak about something which are villi and microvilli. Okay, so think about this right here as the lumen of your GI. Okay, whether it be your duodenum, jejunum, ileum, even in your colon. All right, this is going to be the area where the nutritional absorption takes place. Okay, and as I'm pointing to you is right here. I'm running out of batteries, and I don't know if it's the lighting. The big curvatures over here will be the villi, okay, and the small hair-like particles down here will be considered microvilli. Okay, every single part of these villi and microvilli are surrounded by capillary beds. All right, so this is an enlargement of what I drew grossly around this area. So you're gonna have your arterial capillary bedside and your venous capillary bedside. Remember, in the venous is where most of the absorption takes place, and the arterial side is where most of the oxygen and nutrients are given to these cells. Because remember, these villi and microvilli need oxygen and need to survive as well. Okay, they're aside from absorbing, they're still producing a membranous layer of mucus around this area to also protect. Because even though there's bicarbonate in a small GI, the higher the small GI goes, the more exposed they still are to the acids from the stomach. Okay, because remember, your stomach is throwing in acid-rich food into the duodenum for hours, at least 4 hours, until it's completely empty. So these cells all need a nice rich blood supply. Okay, so the capillary side provides, and then the venous side of the capillary absorbs. Okay, what's going to happen is that your carbohydrates, which are broken down into simple sugars, right? And glucose, galactose, and fructose, all right? Glucose being the primary, galactose is not really used too much, and fructose is used minimally, okay? A high fructose diet will end up being more fat buildup in your body. Your spermatozoa in males does use a lot of fructose. Fructose is their primary energy source. And our body itself our liver can convert some of the fructose into glucose for energy, but it is a mirror image. Fructose is a mirror image of glucose, and our body doesn't do too well in rearranging its particles. So what happens is that a lot of fructose gets stored into fat. Okay. In nutrition, we could go into a lot of high fructose corn syrup and facts and myths of nutrition and all of these essential, non-essential micronutrients and macronutrients. But that'll be for another time. So what happens is that your carbohydrates do get broken down into the simplest form of sugars, and they readily get absorbed through the microvilli. Okay. The reason there's so many little hair-like particles is that the more there is, the more you get exposed to the nutrients in your food. Okay. They displace, and keep this in mind for when we talk about inflammatory bowel disease. Okay, not inflammatory bowel syndrome, but disease. It's going to be very crucial to understand the damage that occurs here, so you can understand how detrimental those diseases can be to somebody. Okay, so carbohydrates get broken down, fatty acids get broken down by lipase, and mix with bile and become myoceles, and then the myoceles get absorbed. Now the myoceles, once they pass this membrane, they bind with apoproteins made by the liver. Apoprotein A, apoprotein B. There's an infinite amount of, I wouldn't say infinite, but there's definitely a vast amount of apoproteins. And they determine what's good cholesterol, what's bad cholesterol, triglycerides, and the effects that it has on the body, which we could go over in cardiovascular and a nutritional video. These fatty particles, chylomicrons, once they become microvilli past the membrane, this is all passive transport, by the way, the majority of it anyways, and they're here in the inside of the lumen of the GI, okay? They can't get absorbed into the capillaries. They're too large, right? The molecules are too large to get absorbed into these capillaries. So what happens is that our lymphatics are the ones that pick them up, okay? Oh, it's working now. Our lymphatics over here do take up these fatty substances, okay? And they do work their way back into the thoracic cavity and into the heart, and they get diffused all over the body, okay? So that's how our fats get taken into our bodies, okay? So just know that they don't go into the portal circulation, but they go into the lymphatic ducts and drain into the heart, and eventually make their way to the liver, okay, and the rest of the body. But by this time, they're attached to certain proteins, okay? They're attached to proteins that allow for them to be transferred properly and not bind to too many things and cause too much damage until the liver sorts them out the way it wants to. So what happens is that we have absorption of all our nutrients, our macronutrients, right, being our protein, carbohydrates, and our fats. Now we have micronutrients and vitamins and minerals that also get absorbed here. So the small intestine is the primary absorption of our body. Okay, the majority of the nutrients that we do absorb is in the small intestines. I want to say maybe 97 or 98%. So you could have a surgery to remove your entire large colon, your large intestines, and you could still live a perfectly healthy life. Okay? Now you wouldn't want to. You need a colostomy bag. You will have to take some supplementation. Okay? It won't be a perfect freedom to where you could eat whatever you want. You will have to watch some of what you eat as well, like low fiber, because once you don't have a colon, you have a colectomy, things change, all right? So you do have to get used to a new way of living, but you could definitely be healthy. It doesn't mean that you're going to have to be depleted in certain minerals. The majority of water also gets absorbed in the small intestines, okay? The small intestines is basically the most important area for absorption of everything. Minerals, proteins, carbohydrates, fats, water, vitamins, you name it. I mean, this is the majority. Vitamin K also gets absorbed here, and in the terminal ileum, with the presence of intrinsic factor, which is produced by the stomach, okay, intrinsic factor produced by the stomach, binds with a vitamin B12 and allows passage through the intestines in the terminal ileum, okay? So that's where we absorbed our cobalamin, okay, which will be vitamin B12, and that's in the terminal ileum, and we do need that obviously for every single cell in our body to not become macrocytic anemic, and a bunch of other things that we need for our metabolism. So this is the way that the GI functions, all right? The GI spends most of its time with the food. So our food is in the GI, in our small GI for the most of the time, and maybe only spends, depending on if you go once a day or once every 2 days, a few hours to more than a few hours in the colon, okay? Some people go to the bathroom 2 times a day, and it's quite normal for them. And some people go to the bathroom and pass stool maybe only once every 2 days, okay? From the terminal ileum to the cecum, things start to change, okay? And the nutrition now, there's emphasis on fiber once you enter the colon. So we've already spoken about all the micronutrients, vitamins, and all that stuff in the small intestines, the basics of how enzymes are needed to absorb and break down certain particles, and how the small intestine has to have bicarbonate so that the acids don't break the enzymes and don't block the enzymes from doing their job. The next video we're going to continue with the colon and the process of the digestion in the colon. One more thing I'd like to add in the ileum, remember as well that whatever bile is left over, most of it, not all of it, but most of it does get reabsorbed in the ileum, okay? So whatever bile is left over that wasn't needed for fat particles to get turned into micelles are reabsorbed in the ileum.